Hi, everyone. Thanks for joining today's session, Utilize QoS to Improve Application Performance. I'm Monique Lucy, Director of Product Marketing at LiveAction, and once again, I am your host for today. And I'm joined today by Lee Cox, Senior Sales Engineer at LiveAction. And he will be diving right into the product demonstration. But just before we get started, I wanted to let you know that you can feel free to ask questions during the session using the Q&A panel on the right. And this session's being recorded, so you'll have an opportunity to play it back after the event. You will get an email letting you know when that's available. And then we've also shared some additional resources for you, and these are located in the Attachments tab. So with that, I'm going to turn it over to Lee for the demonstration.
Thank you, Monique, and hello, everybody, and welcome to this part 2 in our hackathon series. So anybody that was on the part 1 knows that we went through voice QoS troubleshooting, and we used the desktop client and we used the web UI to look at the logical views, and we visualized the DSCP markings in the network infrastructure to find where the DSCP was being stripped off and was being put into the voice has been put into the best effort class. So we're going to continue that theme. We're going to look at voice QoS monitoring and configuration. So this time we'll be using our alerts engine, and we'll be using our reporting function to monitor the QoS, and then we'll be using the front end to actually change the configuration of our QoS policies. So we'll go through 3 different scenarios, and I hope you get a good understanding of how you can use LiveAction and LiveNX for voice QoS monitoring and configuration in your network infrastructure. Okay, so let's go through our first scenario. So that anybody that was on the last webinar in this series knows that we went through a particular scenario where a user was complaining about voice over IP issues in Los Angeles. So we're going to go through the same scenario, but this time, instead of looking at the, we did a cross launch to the underlying packet data and did a deep level forensic analysis on the packets. This time we're going to use the LiveNX front end to fix the issue with the voice over IP traffic in Los Angeles. So I'm on my landing page here, and if I click on the menu icon, and I go into alerts. So hopefully we've been proactive. Hopefully we've got some alerts, and we're already fixing the issue that this user is complaining about. So I'm just going to use LOS there to filter for Los Angeles, and in my description I'm going to put in VoIP to see what alerts I've got for my voice over IP traffic. So notice here we have 2 alerts. So we've got an application alert, and the application alert is letting us know that the voice over IP application is suffering, and it's getting around 10% of packet loss. And we also have a QoS class drop alert. So we've got an alert from SNMP telling us that we have an issue with the particular voice class is dropping packets. So the first alert I'm going to look at is the application alert. So if I click on that, it brings up this side window. So this is the scenario we went through last time. And if I click on the conversation, it takes us to this flow path analysis, this hop by hop view of the route that the flow took to get from the source to the destination, and all the different network devices and service providers the flow traversed to get from its source all the way to its destination. And if we look at the different devices here, it lets us know that the CPU usage, the input and the output interface, the DSCP value. And we can see the DSCP value is expedited forwarding, so it looks good all the way across the path. But notice here on the router Los Angeles, that's where we're getting the issue. So we're getting a high jitter, and we're getting a critical alert on jitter, and we're getting the 10% plus of packet loss. So it seems that it's this device that's having the issue. Also notice that we are stipulating the QoS policies. So we're showing here that we've got an ingress policer for voice over IP on the input interface on this particular device. So the next thing I'm going to do is to go back to my alerts page. And this time I'm going to look at my QoS class drop. So again, if I click on the alert, it brings up this side panel. And this time I want to look at a report, to see what's happening with this actual dropped traffic in this part of the infrastructure for this particular flow. So if I click on report, you see that it redirects me to the actual reporting engine. And this is now showing me the class drops in each of the classes for this policy. So we can see there's only 2 classes in this policy. So we've got the default class and we've got this voice over IP class. And it's dropping packets. So it's not dropping a lot, the average drop is 0.9 kilobits per second. And the peak is 0.34 kilobits per second. And we're looking at the last 15 minutes on this report. So I just want to be sure that that's been happening, has it been happening all day long? So if I click on the pencil button there to edit the report, I'm going to look at the last day and click execute. Okay, so yeah, it seems pretty constant. So over the 24-hour period, we're getting an average drop of 0.08 kilobits per second, and again the peak is the same as the value before. So it looks like a constant problem we've got with the policer in this part of the network infrastructure. So now I'm going to move over to our desktop client. So our desktop client enables us to manage QoS policies. We've got a front end where we can view and we can manage the QoS policies, and it makes it really easy for the network engineer. QoS can be quite daunting. It can be a quite daunting CLI configuration for a new kind of a network guy, but we've built a front end to make it, really, really easy. Okay, so if we look at our router here in Los Angeles, the round circle represents the network device. So in this example, it's a router. We can see the interface here has turned orange. So the whole device has turned orange and the actual interface has turned orange. The square here represents that we've actually got a QoS policy applied to the interface, and it's just turned green again. So this looks like an intermittent problem. So, and it's turned orange again. So this device, it's alerting us. We're polling out to the device. We're SNMP polling to the device, and we're getting constant updates that we're getting intermittent problems with the policer on this particular device. And if I want to view that more closely, I can double click on the device. This brings me up the device structure, so I can see the different interfaces on the device. I can see the inputs and the output direction, and I can see the policies that are applied to the input and the output. So we've got an ingress policer on the input on the gigabit 2. So if I double click on that, it takes me to this page. So now if I look at the table in the bottom right hand corner, I can see my different classes, and I can see I've got my default class here and I've got my voice class. If I highlight my voice class and do view class statistics, I can see the drops. So just like the report was showing us on the web UI, we're getting very intermittent drops that they're quite low, but we're definitely getting drops, and it's definitely an issue. So at the moment, again, you can see that the device has turned green and the interface has turned green, because at this particular moment we're getting no drops. But as soon as we start getting the drops again, we'll notice that the line will go up and the device will turn orange and the interface will turn orange. Okay, so we want to actually modify the QoS policy. We want to enable probably an extra, couple of kilobits per second of bandwidth in this policing profile. So we can see again that we're getting some loss now, and the device and the interface are turned orange. So I'll close this window. Again, I can right click on the class and I can click on Adjust Input QoS. So I can see my class here. I can see my voice over IP class, and it's at 48 kilobits per second. And I just need an extra couple of kilobits per second. So I'm just going to change that to 50. And I could save this to the device, and this would push the configuration to the device. But in most corporate networks, you've got change control. You need to raise a change control document, and you've got a change window. So I just want to preview the CLI, and I can copy and paste this into my change control document, and I can close this. And then when it's my change window, I can use the front end on LiveAction to save the policy to the device. Okay, so for my second scenario, we're going to go through a similar issue to what we looked at in the first scenario, but this time I've got a user in Seattle, and they're complaining about poor voice and video performance. And this time it's going to be slightly more complex. We're going to look at a priority queue and an outbound shaper to a service provider. So on my front page on my web UI again, and again, hopefully we've been proactive, and we've already got an alert, and we're already fixing this user's issues. So if I click on my alerts page, I'm going to filter for the site Seattle, and I'm going to see if there's any video issues there. And we can see we're getting a drop in the video class. So if I click on this particular alert, again, it brings up my side panel, and it's got a few descriptors there. So it's telling me the device and the interface, and it's the interface that's connected to the service provider. And again, I want to view the report. So if I click on that, so now we've got a report of the dropped packets on this particular link. So it's showing us here the shaping policy, and it's showing us the different classes within the shaping policy, and it's showing us the drop rates in each of these classes. So we've got a nice table view here. We've also got this graphical representation. And I just want to make sure that this is, to check to see if this has been happening throughout the day. So again, I'm going to click on my pencil sign here to edit the report. And I'm going to look at the last day. Click execute and see how long this issue's been happening for. So yeah, it seems pretty constant. We've had this issue throughout the day, so it's certainly something I want to look at. Notice here that our input and our output capacity are 2 meg. So this is a connection to an MPLS service provider. The physical interface is a gig, but our actual capacity to the service provider is 2 megabits. So we'll bear that in mind when we go onto the desktop client and look at the QoS policy. So let's do that now. So now on my desktop client, and I'm going to click on my device in Seattle. You can see we've got the different interfaces and the input and the outputs and the different policies on the input and the outputs. And I'm going to click on the output shaping policy. I'm just going to change this to class and class drops. So we can see here, again, the same as we was looking at on the report, we can see that we're getting drops in each of our classes. So I want to have a look at the QoS policy that's applied to this interface. So again, I'm just going to hover over one of these classes, right click and click on adjust QoS. Okay, so it brings up my front end again. Really easy to understand, making QoS, really easy for even a kind of a first level network engineer. We can see, for a start, that our shaping policy is not set correctly, so it's set to 400K. We already know that our link should be at 2 meg, so that's the first thing I'm going to change. I'm going to change that to 2000K or 2 meg. So now, notice now that we've got 91% of the bandwidth available. So I'm going to give my voice queue a nice healthy 0.5 meg, and I'm going to give my video queue a nice healthy 1 meg. And I'm not going to save this to the device at the moment. Again, this is a corporate network and I need to raise a change control document. So I want to know what the CLI is. So I'm going to click preview CLI and I'll copy and paste this and put it into my change control document. And I can either use this, to go onto the CLI in my change window and manually configure the change, or I can use the front end to, push the config to the device. Making complex QoS policy really easy for the user. Okay, so for my third and final scenario, again, we're going to be looking at QoS markings and mismatches within a network infrastructure. Again, we're going to concentrate on voice. And as network engineers, we know that the marking for voice traffic should be expedited forwarding. And we've worked with countless customers who have been troubleshooting voice issues for months and months. And 99 times out of 100, the issue comes back to DSCP markings. So in my last webinar, we looked at a logical view and we saw that the actual service provider was stripping off the DSCP marking. In other customers, we see other issues. So another example is on legacy Cisco switches. If a user turns on MLS QoS, by default, all the switching ports become untrusted, and any traffic going into those ports it loses its expedited forwarding marking and goes into the best effort queue. So we're going to run a report, a really simple report that's going to audit the DSCP markings for Cisco voice traffic across the entire network infrastructure. So again, just clicking on my menu button here. This time we're going to go into our reporting engine, click on View Reports. I'm going to create a report and I'm going to filter for DSCP audit. So we've got a number of predefined reports, and one of them is this DSCP audit report that we can run. We can run it on one device, or we can run it throughout our entire network infrastructure. And that's the report I want to run. So I'll click on that. I'm going to filter for my Cisco voice traffic. I'm going to look at all devices and all interfaces. So I'm going to do an audit of the entire global network infrastructure. Okay, so straight away I can see that it looks like a lot of my traffic is marked correctly with expedited forwarding, but I've certainly got issues with traffic in New York that's in the best efforts class, and again in New York, I've got some traffic marked as AF41. So, I might want to now go on and investigate that and perhaps use the LiveAction client to modify the QoS. And I can schedule this report, so I can schedule it to run perhaps, the start of each week. I can download it as a PDF to, perhaps send it to the operations team, or I can share the URL. So sharing a URL means that you can share just this particular report to different business units within your organization, and they don't need login credentials to view the report. They'll just get redirected to the LiveAction server, and they'll be able to view the report on the LiveAction server without logging in. Okay, so that brings us to an end of the demonstration. I hope you saw the value with the 3 scenarios that we went through, the different ways that we can spot issues with DSCP in the network infrastructure. In the first webinar, we showed how we can use the client front end to find issues. In this one, we've looked at using alerts and using a report to spot issues, and then using the client front end to fix those issues. Okay, so thank you for listening, and I'll pass you back to Monique.
Thanks so much for that great demo, Lee. Appreciate it. And so with that, I'm going to open it up for questions. And we are lucky enough today to be joined by David Azumo, Technical Marketing Engineer here at LiveAction, and he is happy to answer any of your questions. So let me take a peek here in the chat. Okay, so I see a question here, David. What telemetry does LiveAction ingest?
Yeah, thank you for the question. LiveAction consumes multiple forms of telemetry. For example, SNMP for basic device up-down status, interface bandwidth utilization, and so forth. Flow data as well, so IPFix, NetFlow version 5, version 9, as well as SFlow, for example. And that helps us to understand all of the data traffic, the application traffic, who's talking to who, and so forth. Likewise, API data for northbound API connections to controllers like Cisco SD-WAN vManage, for example, or third-party ticketing systems like ServiceNow. And then one final additional piece for the telemetry, we'll collect packets, real-time packet capture, also for forensic analysis via our PCA products, so our packet capture and analysis platforms. And that really helps us to get to the very nitty-gritty details of the network traffic behavior and so forth.
Well, that's great. Thanks, David. Here's another question for you. Can LiveAction provide application performance data?
Yes, absolutely. We can get performance data from a variety of network devices and network vendors via IPFix. In fact, Lee went over a bunch of this in the first part of this webinar series. So if you missed that, please go ahead and take a look at it for voice troubleshooting. So we've worked extensively with our network technology partners to consume their specific IPFix data. Such partners include Cisco, for example, VMware, Palo Alto Networks, Gigamon, and many others. So if the network devices do not provide application performance data though, or if the network administrators want to offload that function for scale concerns, we can generate this data via our PCA or packet capture and analysis products. And what we'll do is we'll take that continuous feed of packet collection and convert that to what we call live flow or IPFix, a format, to send that over to LiveAction for high-level visibility for that application performance monitoring.
Great. And here's another question. Any support for SD-WAN devices like Palo Alto CloudGenix?
Yes, thank you for that question. So we do have a lot of deep dive capability into Cisco SD-WAN, and you probably noticed that in some of our other webinar series. But we also partner with Palo Alto Networks for their CloudGenix visibility, or what they're now positioning in the market as Prisma SD-WAN. So we've been working very closely with Palo Alto Networks to understand and consume all of their IP fixed data. And a lot of that is supported in our latest versions of LiveNX. So check that out. We have a lot of visibility, for example, into their application data, also understanding their QoS model. So it's a little bit different in how they track the specific types of applications and map that to their QoS. So we have that capability to ingest all of that data for Palo Alto Networks. Thank you for that.
Sounds great. So here's one more question. Can LiveNX provide visibility into the public cloud like AWS and Azure?
Yes, thank you for the question. We do collect data for AWS, Azure, and GCP, Google Cloud Platform, and we take a very network-centric approach to our cloud visibility for that support. In fact, to learn more about our cloud monitoring solution, that's actually a good question. Please tune in next time for our third webinar in our Summer Hackathon Series, and we're going to go into a bit of a deeper dive into our public cloud offering and monitoring AWS and Azure and so forth.
Great. So here's another question that just came through. Do you support VMware SD-WAN Velo Cloud?
Yes, another good question on SD-WAN. It's definitely a hot topic. So yes, we do. So we've been working with VMware as well to understand all of their data. So we support the monitoring of VMware devices via SNMP, as well as consume their multiple IPFix templates. So we've worked very closely with their product management team and their engineering team to consume all of that data. So check that out in our latest versions of LiveNX also. Thank you for the question.
Great. So that brings us to the end of the questions. And with that, I will leave you with how we can provide additional help. So you can certainly take a look at our QoS monitoring and configuration session. Review the session again. You can also get a LiveNX live demo, and you can also check out the additional resources in the resource tab. And with that, I'm going to pause because I see another question just snuck through as soon as I said we were at the end of questions. And this one is, do you support ServiceNow?
Yes, we do. So that falls into our connections via northbound API. Connections to various types of controllers and also third-party systems. So in fact, we do support ServiceNow for ticketing integration. So our alerts can be offloaded to ServiceNow, and it can be updated both within LiveNX, and it'll update in ServiceNow, and likewise, you can update the tickets in ServiceNow, and we'll reflect that in LiveNX as well for the alerts. So thank you for that question.
Thanks, David. And I do believe that is the end of questions at the moment. I'll pause there just in case anyone sneaks another one through. Okay, so with that, as David mentioned, you won't want to miss out on our next hackathon episode on cloud monitoring next month in September. So thank you very much for joining. Bye-bye.